Good morning, class. Here's elementary statistics, practice test number 5, module number 5, covering chapters 10, 11, and 12. Here's chapter 12, analysis of variance, or ANOVA, they call it. Here's the pledge. Again, I'm going to remind you when we take the exam. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam. Unauthorized action include, but are not limited to, the use of notes, text, search engines, PowerPoints, AI, or any other resources not explicitly allowed. However, you may use formula sheet, tables, and graphing calculators. All right, chapter 12, analysis of variance. One-way analysis of variance, or ANOVA, is used for tests of hypothesis that 3 or more populations have means that are all equal, as in H0, mu sub 1 equals mu sub 2 equals mu sub 3. In other words, we have more than 2 populations. By analyzing sample variances, one-way analysis of variance is used with data categorized with one factor or treatment. So there is one characteristics used to separate the sample data into the different categories. The populations have the same variance sigma squared or standard deviation sigma. In the F test for analysis of variance, or ANOVA, 2 different estimates of the population variances are made. The first estimate is called between group variances, and it involves finding the variances of the means. The second estimate, the within group variance, is made by computing the variances using all the data, and it's not affected by differences in the means. It helps answer, are the group averages different just by chance, or is there real evidence of a difference? Instead of comparing groups one by one, like using many t-tests, ANOVA does it all at once using variances. If there is no difference in the means, the between group variances will be approximately equal to the within group variances, and the F test value will be close to 1. Do not reject the null hypothesis or fail to reject the null hypothesis. If the means differ significantly, the between group variances will be much larger than the within group variances. The F test will be significantly greater than 1. Reject the null hypothesis. So this is the F test. Again, just like chi-squared is skewed to the right, and the value of F is S1 squared over S2 squared. The ANOVA test is right-tailed because only large values of the test statistic cause us to reject equality of the populations. Other statistical tests, Shafee test and Tukey test, are used to find where the differences exist. Although the t-test is commonly used to compare 2 means, it should not be used to compare 3 or more. That's the synopsis of analysis of variance. Let's look at an example to make some sense out of this here. Okay. Weights in kilograms of cypress trees were obtained from trees planted in a sandy and dry area. They were given different treatments as indicated. So we have no treatments, we have fertilizers, we have irrigation, we have both fertilizers and irrigation. Fill up the table below and use the 0.05 significance level to test the claim that the 4 treatments, 1, 2, 3, 4 treatments, categories or factors yield cypress trees with the same mean weight. So again, notice instead of 2, we have more. That's the concept. Now, what is this table? We're going to go over that. So having said that, there are a few things we need to do here. So I'm going to call it the count n sub I. That means, for example, the first group, if you call it uh, group number one, the count in one, okay, is 1, 2, 3, 4, 5. It happened to be 5 for all of them. N1, N2, N3, N4. That's how we calculate. Summation of x sub I. We add these numbers, these 5 numbers, and we put it here. Same thing for the second, same thing for the third, same thing for the fourth. Then we divide this by n, and n happen to be 5. For each one is the same. They don't have to be. Okay. Then we have the sum of squares. Okay. The numerator and then divided by n minus 1. So now x bar. So we're talking about this one. X bar is summation of x over n. S squared is summation of x minus x bar quantity square over n minus 1. I'm just reminding you everything that we are supposed to know. Now we have the average GM, grand mean, the entire mean, summation of x sub I over n or summation of x sub I over k. So basically add them up and divide by that. And then df n is k minus 1, dft is n minus k, so on and so forth. These are some formulas and we're going to go through them. But again, this is really not done by hand. You don't have to do it by hand, but you need to understand the concept. So over here, n1 is 5. Then sigma of x sub I, add them up. It's 5.95. Then the average, you divide it by 5, you get 1.19. We're looking at just the first group. Now, sum of squares is summation of x sub I minus x bar k quantity squared. In other words, in order to calculate the variance, you have a numerator and you have the denominator. The numerator part is called sum of squares. That's it. So for the first group, so you see how that one is done by hand. We have the average here, okay? So 0.24 minus the average, 1.19 quantity squared, plus 1.69 minus the average quantity squared. So that's what it is. So each x, subtract from it the average and square it and add them up. This is what we have here. Now we are going to divide this number by n minus 1. Remember, for this group, n1 is 5. So 5 minus 1. So divide this number by 4. Divide this number by 4. You get 0.39, almost 0.4. So I've shown you how to evaluate this step by step for each and every one of them. If you know the first group, we're going to repeat it for the second, third, fourth. And I hope you see why we do not do it by hand, because although we have only 5 pieces here, it makes it very difficult to do it by hand. So nobody expects you to do it by hand, but I want to make sure we understand the concept. That's it. All right. So what we have here is what we had over there, and now we're going to continue working on it. So some of the calculations that are happening here. When we want to take the x bar for the entire thing, that means start with this one, go all the way down, this one, add up all these values, all of it, and divide by 20. The other way that can be done we already have the average for each group. You can add up the averages and divide by 4 groups. Okay, so the second method, summation of x of I bar divided by k. Again, remember we have 1, 2, 3, 4. K is the number of categories. 1, 2, 3, 4 is the number of categories. So since we have already calculated the average for each category, just add up the averages and divide by 4 categories. It will give you exactly the same answer. So grand mean x bar sub t or x bar sub gm, depending upon the text or technology, they may use t for the total or gm. Grand mean is this number 1.0935. So we need that. SSB, the between sum, if you will. M sub I, x sub I bar minus x bar gm grand mean. And so for each group, we are going to use the n. For example, for this group, n is 5. By the way, n happen to be the same for all of them. They may not be. That's why we have that. Otherwise, it's very straightforward. So 5, and then you multiply that by the mean minus the grand total. So what is the mean for this group? 1.19 minus the grand total, and then square it. You do the same thing for the next one and the next one and the next one and add them up. So look at just the first one. 5 times 1.19, just the first group, minus this number 1.0935 and square it. You do exactly the same thing for the second, third, and fourth and add them up. And this is SSB. So it goes here. How many categories? 4. So k minus 1 is 3. And remember, degrees of freedom is n minus 1. For this group is 5 minus 1. 5 minus 1, 5. So therefore, the entire thing minus the number of categories, n minus k is 16. Those are the two that are used. So k minus 1 is 3. N minus k is 16. Capital N minus 1, obviously, you add them up. So I wanted you to see the second column. Now, MSB, okay, the mean square is what we just found divided by k minus 1, okay? The mean squares, okay, we are going to use this number divided by k minus 1, which is 3. So this divided by 3 goes here. So divide this one by this one, put it here. Now, the within error is x sub I minus x sub k quantity squared and all the way to the end. That is within, which means all you have to do, because we've already calculated this, n sub I minus 1, remember this was 5, so minus 1 makes it 4, okay, times S1 squared. This one happened to be 4 again. Again, they may not be the same. Times S2 squared and so forth. This is the within. This is one way to calculate it. There is another way of calculation. This is the fastest and easiest. And when we come up with the answer, we put it here. So a quick recap on that. The within error or sum of squares is as follows. The sum of squares over here, remember, we had to divide this by n minus 1. We want just the numerator. That's the idea. So that's why we multiplied by 4, just the numerator that we had for this last piece. The same thing for this one, the same thing for this one, the same thing for this one. We want to add them up. That's why we multiply by 4. Okay. Now, these two add up to give us the total. So add these two numbers, SS total. Okay. Now to get this one, we divided this one by this one, and to get this one, we're going to divide this one by this one. So SS within divided by n minus k, meaning 16. Okay. Or take the average of the standard deviations, and that gives us this number, 0.271373. Then F is the ratio of the two numbers. These two numbers is the F. And we put it here. So the idea was to go through that to fill this up. On a normal basis, you don't have to do this by hand, as I've mentioned. So what happens, they give you some of them, and some of them are missing. You have to fill up the table, okay? Or this is given, put it into a calculator, see what happens. So let's continue on that thoughts. So we are continuing with this question, and we wanted to fill up the table. And this is the table that has been already filled up from the previous page. And so we're going to do the test of hypothesis. Step one, H0 mu1 equals mu2 equals mu3 equals mu4. Why 4? There were 1, 2, 3, 4 categories. And that is the claim. And to undo that, H1, at least one of them is different. So at least one of the treatments has a population mean that is different from the others. That's how this one works. So we need a test statistic, and that is the F distribution value. And FTS stands for test statistic. It's 0.389741. And we saw in the previous page how we calculated that. Needless to say, this has more decimals. Critical value, FCV. Find the critical value, number of groups factors, K is 4, degrees of freedom is K minus 1 or 3. Total sample size N minus K, that is 16. So alpha 0.05, CVF is 3.23887. So this is degrees of freedom for the numerator. This is degrees of freedom for the denominator. Alpha is 0.05. You have different tables for F distributions. You want to make sure, first and foremost, alpha is 0.05. And you look it up, you have the answer. Or just the technology gives you the answer. So here's the critical value, and the test statistics puts us way into the non-rejection region. Therefore, we failed to reject H0. So that's the number, the p-value, by the way. The p-value is larger than alpha 0.05. Both of them, they result in the same thing. Now, step 4 decision. Fail to reject H0, clearly. So we go back. If we are not rejecting H0, we are not rejecting the claim. The claim becomes true, and we reinstate as follows. There is sufficient evidence to support the claim that 4 population means are all the same. We conclude that the 4 treatments do result in cypress trees with the same weight. That's important to understand the concept. Given readability scores summarized in the following table and a significance level of alpha equals 0.05. By the way, when you do the research yourself and you need the alpha, on a normal basis, everybody uses 0.05 unless you're dealing with like medicine and so forth. You make a title like 0.01. Use technology to test the claim that the three samples come from population with means that are not all the same. So the point I'm trying to make, in some cases, alpha may not be given. So we have three different riders: Clancy, Rowling, Tolstoy. And so Clancy, what is in, okay. It so happened 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is 12 for all of it, okay. But you're going to calculate the X bar, okay. It's very simple to calculate the X bar. Add them up, divide by 12. Same thing for each row, put them here. And S, summation of X minus X bar quantity squared over N minus 1. So this just comes from elementary statistics, not a big. And this is the table that has been created by Excel. Okay, as you can see, pretty much everything that you want is here. You just need to understand the table. Okay. Excel source, okay. Sum of squares, degrees of freedom, mean, F for the test statistics. For the critical value, this is the p-value. So very simple. And obviously you can see this to add up to this to add up to this. Okay, if you divide this one by this one. So divide this number by this one, you get this one. This one by this one, you get this one. Add these two, you get this one. So that should be pretty straightforward. So having said that, H0 mu1 equals mu2 equals mu3. And H1, at least one of them, is different. And this is the claim. To make sure we understand why, use technology to test the claim that the three samples come from populations with means that are not the same. That becomes a claim. So we use the table, we use the table that is available to us here for the test statistic, critical value, p-value, and so forth. Obviously, this is the test statistic. F equals 9.4695. This is the critical value. Please understand, we had three categories, okay? And degrees of freedom would be 2 for the numerator. For the denominator, we had 12 n minus k, 12 times 3 and then minus 3, because we have total of 36. This 36 is 3 times 12, everybody. Let's try it. This entire thing, there are 12 times 3 pieces. So when you're using the F distribution table, first you choose the table that has alpha 0.05. Degrees of the numerator is this number 2, and the denominator is this number 33. And obviously, it's given to us 3.2849. And clearly, the critical value 3.2849, and test statistic is much larger than that. It's way into the rejection region. And if you look at the p-value, it's less than alpha 0.05. Both of them result in the same thing, which means reject H0. Again, remember, clearly this is in the rejection region. When p-value is less than alpha, reject H0. So if you're rejecting H0, loosely put, you accept the H1, the claim becomes true, and you rewrite as follows. There's sufficient evidence to support the claim that the three population means are not all the same. We conclude that those books have readability level that are not all the same. Now, what I want to add here, I want to also show you the technology as far as TI is, concerned. So TI calculated one way and over. First, you clear the list. In this case, L1, L2, L3, we need 3 of it. Okay. And then stat test, ANOVA, L1, L2, and so forth. So we are going to Fill up the L1 with Clancy, L2 with Rowling, okay, and L3 with Tolstoy. Then all we have to do ANOVA, okay, stat, test, ANOVA, put L1, L2, L3. That's all. It does the work for us. What do we notice? First of all, the moment you see the arrow down, then there's another page. And then what are those? Take a look at what we have here. So this was test statistic. This was the p-value. Please understand the p-value, 5.6 times 10 to the power of minus 4. And I'm going to write that because I want to make sure that you understand. This is important. This is 5.521 times 10 to the power of e minus 4. That means this. So which means this is the decimal. You have to move it. And that's why it's close to what we have here. So it's important to understand the meaning of e. Having said that, let me erase my work and continue with the thought. So we have the f, we have the p-value. What else do we have? Okay, so these are the two values. Look at this one. Degrees of freedom, 2 over here. SS is this number, of course, with a lot more decimal. Okay, and MS is this one because if you divide this one by degrees of freedom, happen to be 2, you get this. And look at this one. Degrees of freedom is 33. Sum of squares is this number. Divide by 33, you get the mean square. So everything that is calculated here through Excel is also given here. So I hope everybody's clear on that.